So I'm Dr. Josh Bonde. This is Becky Hall. We're with the Nevada Science Center. I'm the Director of Research. Becky's the Director of Education. And we are here in the Diamond Mountains of Central Nevada. So for those of you who aren't from the States, Nevada is one state east from California. And so we're in the central part of the state. This is a mountain range which is right outside of the little town of Eureka, Nevada. Eureka is historically a mining town, and so the reason that there's even a town here is that people came back here in the late 1800s, early 1900s, trying to seek riches, mining gold and silver. We have some pictures here of what the town looked like back in its heyday. It's still a town today. It's a little sleepy town. Its nickname is the friendliest town on the loneliest highway in the United States. So here's a historical photo of what the town looked like in 1930. So you can see kind of the camp and the mountains around us. Kind of gives you a better sense of what the geography around us looks like, rather than just the red rocks you see behind me. It's home to the oldest opera house in the state of Nevada. So one of the horseshoe-shaped upper decks. So this is one of the last classic opera houses from the mining era of the Western United States. And then Eureka today, as you're coming into town on the loneliest highway, US 50, it's again kind of a sleepy town up here in central Nevada, but still pretty lively in culture. So with that, up here in the Diamond Range, we are up in the Pinyon Juniper woodlands. And so the Pinyon Junipers are, if you look behind me, are the yellowish green trees are the junipers. And then the lighter green colored are called pinyon pines, or Pinus monophylla is the scientific term. So I'm a Native American, and so my tribe and other tribes in this area of the United States would collect the pine cones from these trees. And then within the pine cones are pine nuts. And so this was a staple of food for lots of indigenous tribes in this part of the world. Crack them open. There's a nut inside, and that's what the edible part inside of the nut. Birds and squirrels and all sorts of other animals compete with people for the pine cones and the pine nuts, but that's kind of a cool natural history aside of this part of the world. The mining story, so what drew the miners here, and what me and Becky just found yesterday when we were out here hiking around, this is the greenish stuff is copper ore. The purplish stuff is another type of copper ore. And so what the miners are looking for are rocks like these on the surface, which tell us that there might be minerals that they're interested in the subsurface. So historically, the miners were looking for gold and silver. Today, miners are still exploring these hills, looking for minerals like molybdenum and vanadium. So it's still a very prolific mining district to this day. And the rocks which contain these minerals that are important for economic purposes are igneous rocks. And so those are rocks which form as a result of volcanic activity. And they're also looking for rocks which have been altered by hot geothermal fluids. Those hot fluids can also emplace minerals, which are important. Now, even though that's the story of why Eureka's here, the story of why this is an important part of Nevada history in this part of the world, that's not necessarily what me and Becky are looking for here. So, Becky, yeah, go ahead. So Becky's going to talk about what we are doing here, being the scientists that we are. So I'm going to hand, if you want to look off into the distance, this is the Diamond Range, kind of seeing US 50 in the foreground. You make out the Pinyon Juniper as you look around the landscape. In the low grounds, those are...
All right. I'll take over, Josh. Okay. So Josh kind of started about the minerals, the town of Eureka. So what miners are looking for are the igneous rocks. But on the outskirts of towns, we have these little slivers of the Cretaceous. So the Cretaceous is when we have the peak of dinosaurs. And so it's me and Josh's job to come out here and look at these rocks. So like Josh said, the miners are looking for the igneous or the volcanic rocks. Fossils would not be preserved in hot lava. So we are looking for sedimentary rocks. Sedimentary rocks can range anything from like mudstone. So if you look at the ground right here, a lot of mud. So and then sandstones. And then we even have bigger class, let's see, called conglomerate. So you can see the bigger rocks inside this rock, right? Made out of a whole bunch of different class sizes. So this can also tell us as paleontologists what the environment was 110 million years ago. So the rocks that we're looking at today, 110 million years old, and it can tell us what the environment was and the energy flow of water. So 110 million years ago, there would have been lakes and rivers flowing to the east from the mountain ranges to the west. And more high energy would have these larger clasts being moved, where low energy would have this mud. So how do we find dinosaur bones? That's almost the #1 question we get all the time. First, we have to look at the right age rocks. So if we're going to be looking for dinosaurs, we're going to be looking in the Cretaceous, maybe Jurassic. If we're looking for Ice Age mammals like mammoths, we're going to be looking for Pleistocene. So here we know we have Cretaceous rocks 110 million years old. So what we have to do is hike, put our boots on the ground, look at the ground, and try to find fragments of bones. So I'm going to talk about a little bit about our tools that we use. And then I'll send it back to Josh and talk about some of the animals and dinosaurs that we found out here. So just yesterday, we were out hiking around trying to look for new dinosaur sites, checking up on some old dinosaur sites. And first thing you gotta have is your pack. So our pack is what we leave camp with all day long, has our snacks, our water, and our tools. So I'll talk a little bit about our tools. So what do we have here? So a couple different size hammers. This is a rock hammer, maybe crack over something, move some dirt around, and a paleo pick. You can see the difference in size, a little bit heavier. This will help us move the dirt if we need to move the dirt around a little bit quicker. This is a more precise, a little bit bigger. We don't usually use these too often around fossils because fossils are fragile and these will end up breaking them. They help us move the dirt around it. All right, what we do use more often are smaller tools. So I'll get into that. Some you probably seen it, but not used in the way that we use it. So a trowel, this is nice, easy way we can move the dirt around, get around a bone. Paintbrushes, so we're not painting any pictures out here, but we can use these to gently brush off bones. A dental pick, so you might have seen this getting your teeth cleaned at the dentist. Nice sharp edge, you can get real detailed, kind of chip away at the dirt if you needed to. And that goes with an awl too, a little bit bigger. So these are our tools that we all keep in our pack when we come up to a dinosaur site to kind of examine what we have. If it gets larger and we actually have an excavation, that's a whole nother story. So I kind of brought an example. We bring some in our packs. We keep a little bit of a little cast, instant cast that we can make on a bone. But most of the time we have to plan a trip with a lot of plaster and come out with a team to make a huge plaster jacket to bring that back. So I'll actually show, so we found a new dinosaur site yesterday, like I said. It's maybe not what you think of. Sometimes we find a huge bone already intact in the ground. Otherwise, it just kind of comes out in pieces. So I have this whole bag from one site that we found yesterday. But the cool thing about having our lab down in Henderson, Nevada is we can bring these pieces back and they glue back together. So here's some bones that we found yesterday. Second question we get is, how do you know they're bones, right? They look like rocks. If you look closely, I don't know if the camera can pick it up, but you can see different texture in the bone. Like almost looks like bone. Look at the more spongy look to it. And it doesn't break like rock. You can kind of see how these pieces kind of came together, broke apart. This was about a 2-foot long bone that we kind of all picked up and we'll put back together in the lab. So I'll send it back to Josh because we brought some examples of some of the other bones that are identifiable. So this right now, we don't know what kind of bone it is or what kind of dinosaur it came from yet. But that's the important part about doing our lab work, is that we can put these bones back together and kind of answer those questions. So let me shoot it back to Josh, and then he'll show you some other identified bones that we have found in these hills. All right.
So some cool show and tell. So one of the interesting things about doing paleontology is that you want to get a story for the entire environment in which the animals lived. So Becky was talking about the different types of rocks And so the different types of rocks tell us ponds, rivers, lakes, things like that. But then the fossils tell us who is living in that environment. So here, we have a couple pieces of petrified wood. So one of the really cool things, like if you want to think about this kind of philosophically, is that each layer within either pieces of these petrified woods is a year in the life of this plant 110 million years ago. And so we can see that there were plants that were growing across this landscape, along with the animals that I'm going to show you here in a moment. These are probably from coniferous types of plants, so not too distantly related from the pine trees and the junipers that we see around us. All right, so we do get invertebrates. So these are some snails that were living in these lakes that were here in Nevada 110 million years ago. So here they kind of have a high spire. Paleontologists who are experts in snails can tell you whether or not these are water snails or land snails. I'm not an expert in snails, so I'm not sure. So it's one of those collaborative things about paleontology, is working with experts in other subdisciplines. So we'll be sending these off to figure out where they lived and how important they actually are. I like to call these Cretaceous escargot. Some other animals. These are pieces of turtle shell. So that just like today, there's turtles living in ponds and in rivers. We had turtles that were living in these ponds and rivers here in southern Nevada, or excuse me, in central Nevada. So again, 110 million years ago. You can faintly make out the little texture on that shell piece right there. Based upon that single fragment, we know this is a turtle genus called Glyptops, which was really common from this period of time from Nevada all the way over to Colorado in rocks of similar age. So kind of a widespread turtle that was living in waterways across Western North America. And what else do you have in waterways? If you have turtles and you have snails and it's kind of a warmer environment, you also get crocodiles. And so if you've ever seen the back of a crocodile or an alligator and it looks all bumpy, that bumpiness are these. These are skin bones inside the skin of the crocodile. And so it's kind of a chainmail of bone called osteoderms. So the bumps on it are just kind of the bumpiness of, let's show the texture of the bones themselves. So we know that crocodiles were cruising around these rivers and lakes also 110 million years ago based upon these. And we've also found some really big teeth. So these were not small crocodiles. These are probably about the size of American alligators cruising around. One interesting thing though, in rocks a little bit younger from southern Utah, which is the adjacent state, there's a giant crocodile called Deinosuchus, which was a dinosaur-eating crocodile. So maybe a small dinosaur coming up to the rivers of central Nevada also would have met its demise by an ambush from a crocodilian. Also swimming in these waterways were fish. And so this one little rhombohedral, shiny rhombohedron here is a fish scale. So if any of you have ever gone fishing, or if any of you have ever Googled a garfish, which are not common in Nevada, or which are not found in Nevada at all today, found more over in the Mississippi part of North America. These were common fish in waterways of Western North America during this period of time. So we had garfish also swimming around with the turtles, with the crocodiles, and they've also found minnow fossils and things like that also from these rocks. Then, of course, as promised, the dinosaurs. So here, the texture on this bone is really weird. It's kind of crosshatch, some this way, some that way. What this is, it's another osteoderm, just like the crocodiles have, except it's not from a crocodile. It's from an armored dinosaur. So the armored dinosaurs are like Ankylosaurus, Nodosaurus, Stegosaurus. Probably this one is from an ankylosaur. So these were really common during this period of time. So we had armored dinosaurs stomping around 110 million years ago here in central Nevada. Some other dinosaur species. These are just some dinosaur bones. So this is part of an arm bone to a dinosaur. So I don't know if you can make out that grain that Becky was talking about, which shows that it's bone rather than just the surrounding rock. Here, we'll do this. Sometimes bone sticks to your tongue too. Don't worry, this is 100 million years old. There's nothing gross on it anymore, but yeah. So this is kind of a little dinosaur bone. This is part of a bone from an animal we don't know who left it yet. So this is one of these digs that we're still working on, and we're still excavating. This just looks like a rock, right? Probably from where you're sitting at your desk. If I turn it around, this entire thing is part of a single bone. The animal that left this bone behind is probably something 20 to 25 feet long. We don't know if it's a meat eater yet. We don't know if it's a plant eater yet. So we're still excavating to try to figure out who left this bone behind. So this is all real active research that me and Becky are working on here in Central Nevada. So we come up here a couple times a year to try to excavate, and we have active sites all across Central Nevada, Southern Nevada, trying to tell the dinosaur story here. So based upon our research so far, again, we have the armored dinosaurs like I just showed you. We have iguanodons, which are about 20-foot long, two-legged plant-eating dinosaurs, which were the ancestors of duck-billed dinosaurs, which are a little bit more popular, a little bit younger rocks. We also have sauropod dinosaurs, so the ones with the really long necks and the long tails. We have pieces of them. We also have raptors. So just like the raptors from Jurassic Park, we have pieces of them from these rocks. We find their teeth everywhere. And we've also found pieces of eggshell from them. And so that tells us that they're laying their eggs and raising their babies here in Central Nevada, also 110 million years ago. And the really interesting story about this research project and why it's so fun to bring you out here is that because this is active research, we don't know who else is coming out of the rocks. And so we're still digging, we're still trying to tell this story. So maybe you can visit the Nevada Science Center website down the road, or maybe you can watch a future virtual field trip from out here on the rocks, and we'll be able to tell you a little bit more about who's out here and who we've dug up. So with that, I think we can open it up for some Q&A if you're ready, Ralph.
Yeah, absolutely. So we have a question from one of the students right here in Nevada, and she wants to know, are there multiple dig sites at a main dig site? Like, are there like mini dig sites at a big dig site?
Are there lots of dig sites?
Yeah, like, you know how you guys find one dinosaur, and do you tend to find that there could be multiple dinosaurs, like they were in a pack, and then you have multiple dig sites going on right near each other?
So the way it works is that we go out prospecting, and so short answer is yes, we have lots of dig sites across the state, and lots of different aged rocks. And so we have lots of dig sites, in particular in these Cretaceous aged rocks. How the dig sites are related to one another is work that we have to do down the road. So that's the geology part. So where we go out, we actually measure the individual layers of rocks out there and see how they relate to one another horizontally over miles across. But typically, if you think of a modern floodplain, you're going to find a dead cow here, a dead cow there. So we're essentially just finding the random dead cows on the landscape that aren't really related to one another.
Interesting. So we have a question from one of our students.
If you look, oh, good.
Oh no, you were saying, go ahead.
Oh, I was just saying, like, to look at the layers of rock, like I mentioned to the previous question, if we look off to this direction over here, you can, fumbling the iPad, we're good. You can see kind of the different colors and the different layers. That's what we're looking for when we're looking at the different layers and how they're related to one another.
Interesting. So we have a question from one of our students in Italy who signed up for this. Mav, I'm going to go ahead and unmute you to where you can ask your question. So go ahead, Mav.
Hi, I would like to know, how do you feel knowing that the fossils you find have been in that exact position for billions of years?
How do I feel about the fossils being at the exact spot for millions of years?
Yes.
It's really kind of mind-blowing when you think about it. Like, you're standing on the same spot, your feet are in the same dirt that dinosaur was living on 100 million years ago. So with that kind of sense of awe that animal has been there for tens of millions of years, also comes a deep responsibility. So as soon as you start to uncover and dig up a bone, you're taking responsibility for that bone for the rest of, should be for the rest of human history. So that bone has to be able to, you have to be able to make sure you have the proper tools like Becky showed us just a moment ago. to make sure that that bone it can survive. So lots of future scientists, lots of future students like you guys can study it and enjoy it in the future.
And I'll add that it's also, we've been working on this for a few years, and we're trusted with the federal agencies or state park agencies when we get our permits, that we'll collect these responsibly and then take care of them before we give them back to them. So when we give them back to them, they'll either go to their own housing collections or their museums. But even when we're finding new sites, like yesterday when we found a new site, it's still exciting every time. So it doesn't wear out. We don't take it for granted, that's for sure.
Right.
That's good. We have a question from Susanna, a student in New York City in Queens, and she wants to know, how did you find the copper? Was it on the ground or inside the ground?
Because this is what we call a mining district, so these are areas that are kind of designated for how many minerals are actually in the ground. We just found it on the surface. That's how much mineralization or how many economic minerals are in the surrounding rocks, and why there's a town here and all the mining history is because there are so many minerals. So yeah, we were just walking up the hill and, oh, there's a bunch of copper ore. So that's kind of one of the cool aspects of doing this geology work, is that it doesn't matter if you're a paleontologist or an economic geologist, your eyes are always on the ground.
And that rock that we found with the mineral in it.
Becky, your microphone, hold on, Becky's microphone is cutting in and out. Just wanted to give you a heads up.
Okay, can you hear me now?
No, the microphone is like super faint.
Oh, no, it's okay. I'll just let you know. I was just going to tell them that
Oh, now we can hear you.
Oh.
Now we can hear you.
Oh, okay. I was just going to say that piece of mineral rock was not part of this Cretaceous rock formation we're looking at. It washed down from the mountain above us, so it's a little bit different.
That's interesting stuff. So we have quite a few questions for you guys. We'll try not to take up too much of your time. So Ms. Kulikowski wanted to know, when COVID is over, is there going to be a way for the Nevada Science Center to set up volunteers to come out, or students to come out to any of the dig sites to see what it looks like in person?
Yeah, so we haven't, so our lab, we just set up our new lab down in Henderson, Nevada, down in the downtown district. But yes, so as soon as COVID is, and our restrictions are lifted, what we're gonna do is we're gonna have an online, kind of like a reservation system, where you can come down and see our working lab. So stay tuned, we'll get that up on the website shortly.
Very good. And we will get out all the information for the Nevada Science Center website. I'll put it out in the chat. We have a question from Lucrezia in Verona, Italy. She wants to know, where and when started both of your passions for paleontology and geology?
My passions for paleontology started when I was in elementary school. I grew up
Now your microphone is cutting out, Josh.
Answer it.
Okay, I'll answer it first, and then maybe I'm sorry.
You're good.
Same with me. Dinosaurs or fossils in general have always been a passion and an interest of mine. Going to museums when I was younger, and it was just something that, don't get discouraged. Sometimes people try to discourage you away from something that maybe they didn't find the passion for, or maybe they didn't think a career was possible. But put that aside, if you really like to do it and you're really interested, go out and continue with school, study geology, biology, and there's tons of different avenues in which you can be a paleontologist, whether it's in academia, so a professor at a college, a museum or a science center, or even consulting. So going out, working for private industries, making sure that fossils are taken well care of too. Hopefully you're. Am I
back yet, Ralph, or is mine dead?
You're going in and out, man. We gotta get some new microphones for you guys.
I'm sorry, guys.
You're fine.
Yeah.
So I'll just keep shelling the questions over. They want to know, is it hot where you guys are at, or is it moderately temperatured?
So right now we're about 6,700 feet. So it's a little bit cooler. The wind just picked up, of course. That's usually how it goes when we're doing virtual field trips. So right now it's cool. It's probably in the mid 60s. Last night camping, got chilly. I think it got in the 20s. But they have a winter here. We're in central Nevada. So here they'll have snow. They'll have a full 4 seasons here. Unlike southern Nevada, where we don't see much winter unless you're up in the local mountains.
That's great. And we have a question. One of the students wants to know, will the Nevada Science Center ever consider doing a junior paleontologist program?
So yes, so we have all these like ideas. We're brand new. So we're 2 paleontologists that had lots of great ideas, and we're trying to bring that to you. So we want to do a junior paleontologist, not just for young learners or high schoolers or college students, but for all learners. So one of our goals is to have interest for all ages and not just geared towards a certain age. But yes, we'd like to have programs for going out and getting in the field and learning what we do by getting experience that way.
And, yeah, we appreciate you guys. Sorry to put you on the spot with that one. So yeah. We have a number of questions regarding how can students become paleontologists? Like, what is the background as far as what kind of schooling would you need?
So to become a paleontologist, there's not a certain certificate usually you get. You want to go to college though. You want to do well in your science classes. So like I said, geology classes, because you have to understand the rocks where these bones you're gonna find these bones. Biology, because you're looking at ancient animals. So you kind of have to know a little bit of both. So both me and Josh studied both geology and biology and environmental science. And then depending on what your personal goals are or professional goals, master's degree or a PhD like Josh. And it really depends on what kind of career route you would like to go to. So lots of reading, also experience. I know Josh would say is finding a good mentor and getting out and volunteering at a museum or a college or a science center where you can get that experience and really learn if it's something that you want to do. A lot of people think, it's not glamorous what we do. We get dirty. Sometimes we're camping 2 weeks at a time. Some people don't like the field aspect of it, but that doesn't mean you can't be a paleontologist. We also have paleontologists that work in labs only. So they don't do the field work. Someone does the dirty work for them, and they're in a lab either preparing fossils or researching them. So it really just depends on what your interests are and just getting that experience to know what you would like to do.
So we just have a couple more questions and then we'll let you guys go. I put in Josh and Becky's email for the Science Center there as well as their website. So if anyone has any further questions, and if we didn't get to your questions, we apologize. We try and get to all of them. We have a number of questions as far as what is the process when you guys find a fossil? What do you do in the lab versus what do you do in the field?
All right, so when can you hear me okay?
Yes, you're crystal clear now.
All right, so when we come upon a fossil, it's the process of prospecting. So just like we were talking about mining, as paleontologists, we also go out prospecting. So walking around the hills with our eyes on the ground. When we encounter a fossil, the first thing we do is we assess how much of it's there. Is it just an isolated little scrap of bone that we'll never be able to identify? Or is it something that goes into the ground and is getting much bigger like the bone we found yesterday, which is already 2 feet long? So once we find it, we assess it, we stabilize it. We have special glues that we use for that. And if we have to leave it and bury it and come back with better tools, we'll do that because we don't want to tackle it unless we're ready for it. So once we recover a fossil, we bring it back to the lab and we undergo the process of what's called fossil preparation. So that's getting the fossil ready to be curated in a museum. And so that's gluing the pieces back together, that's stabilizing the bone. Sometimes they need special cradles if they're really fragile. So those are the 2 different aspects. So in the field, we stabilize it, collect it, bring it back. And then in the lab, we do the nitty-gritty work of making it look pretty and permanently stabilizing it.
Going on there. So the kids want to know, what was the first fossil that either of you guys found in the field?
What's the first fossil you ever found in the field? A trilobite. Becky says a trilobite. which are little marine arthropods that lived at the bottom of the ocean from about 540 to about 300 million years ago. So those are actually really fun to go find in the field. We've taken our kids out to go looking for them. That's actually a really great entryway for finding fossils. Me personally, there's a chalk quarry outside of my hometown of Fallon, Nevada, which is not too far from where we're at right now. And in those chalk quarries, we used to go collecting fish. So within the layers of chalk, you'd find these little whole fish. And those were some of the first fossils I ever found.
It must have been exciting for you guys to find that out. Before we let you go, can you tell the group as far as what Nevada Science Center events we have coming up?
Yeah, let me hand it over to Becky real quick for that.
Science Center events? Was that the question?
Yeah, if you could just tell them before we let you go, what kind of events do we have coming up with Nevada Science Center? And where can they go to?
So we have, right. So right now we have scheduled virtual field trips to the Valley of Fire State Park here in Nevada, where we also find some Cretaceous dinosaurs and also Jurassic dinosaur tracks. That's going to be on, I'm going to get it wrong, the 22nd of October. And then in November, we're going to be doing Ice Age Fossils State Park here in Nevada, down in the Las Vegas Valley, where we're going to visit their collections, which houses their mammoths, tusks, and all their Ice Age mammals. And then we also have a virtual event with Dr. Bernard Means, who takes fossils that are already in collections and digitizes them to make them 3D models, which is a kind of another interesting aspect of paleontology or archaeology in getting the access out to everyone else. So our website, these events will be getting put up. We've been kind of busy, so those will be put up this week for registration like you did on this one. And then as soon as COVID is open, or COVID restrictions are a little bit more lifted, we'll be having more events. So just kind of stay tuned. And unfortunately, it's just, you know, the year of 2020 where we keep finding obstacles to get in a way to launch some of our bigger programs. But those are, hopefully by the end of the year, we'll have those up and going.
Well, thank you guys for hosting this event, and thank you all for tuning in, and we appreciate you all, and we hope you guys walked away with something. So everyone have a great day. Bye.
Thank you.